I'm going to work through example 1-8.2 with you. So open your textbook up to example 1-8.2 and kind of work on it on graph paper with me. You're expected to have what I'm graphing on GeoGebra on paper in your notes. On graph paper, graph segment AB. I'd like you to notice that the line over the capital letters A and B in your text does not have arrows on the right and left, so it's indicating the symbol for segment. So we know this is not a line. A has coordinates 4, 1. I'm going to use the point tool, and I'm going to put a point where I think 4, 1 is, and it's close. So I'm going to just go to properties and nudge that over. Where did properties go? To the point 4, 1. GeoGebra will let me put that exactly on 4, 1 simply by changing the label. Not sure why that showed up, so what if we turned that off? And check what the other point it wants me to graph is. That's B at 2, 5. So that's going to be somewhere around here. I'm looking for point B at 2, 5. So you're expected to have this on your own graph paper. So while I'm fixing this point to make it 2, 5, you're graphing it on paper, right? There we go. Oh, and I don't want the name C, so I'm going to change the name of it. There we go. And it's a segment, so let's go ahead and build the segment, BC. We're asked to use tracing paper to rotate this segment 90 degrees counterclockwise around the point of origin. So let's put a point at 0, 0. And let's use the rotation tool. It's under transformations. Rotate this figure around this point 90 degrees. Counterclockwise is my first direction. And we have the graph for A prime, B prime. And I see that my label didn't show up for A prime, and that's because I don't actually have a label on A, so I'm going to change that. Name and value. And I'm going to change A prime to name and value, so that we can see that the expectation we have for these 2 points, which is that the X and Y values will switch, and perhaps a sign will change, has happened. A was at 4, 1. A prime is at negative 1, 4, because the values for the X's changed right here at the origin. Positive to the right, negative to the left. Did the same thing happen for the points 2, 5 when going from quadrant 1, where we have a positive XY value, into quadrant 2, where we have a negative positive XY value? And yes, we see that the absolute values for X and Y changed places, and the sign for the X value changed because now we're on the other side of 0. We're then asked to compare the lengths of and angles formed by the line segments that connect points A, B, A prime, and B prime to the point of rotation at 0, 0. So let's first add those segments. There's B prime to 0, 0. There's B to 0, 0. And let's change the color. Hopefully you're working with a highlighter or colored pencils. Let's make these both red. I guess that's really pink. And what do you guess that the value of that angle is? Let's go ahead and measure that angle. And it's clear from the box that is created when we make that angle is 90 degrees. So that's what happened when we connected the point of rotation to the point on the original and the point on the copy. Let's see if that happens for the A's. Here's A prime, and here's A. Let's change the color. I'm not sure if I got the right segment or not. I did. I don't know. Does that look like 90? I can't quite tell, so I'm going to measure it. And it also boxed itself right into a 90-degree angle label. So we can see that the angles formed by connecting the image points and the copy points to the origin or the point of rotation are 90 degrees. Let's see if we can get a value for the lengths of these segments. E is 4.12 units. Let's see if D is also 4.12 units. Indeed it is. And let's compare C and B. Really, we can compare C and B over here on the left, and they're both 5.39 units. So the original image B and its copy are the same distance from the origin. The original image A and its copy are the same distance from the origin. And when we connect the original point to the rotation point to the copies point, we get a 90-degree angle. If we change that rotation, that will change the angles created. So in a text box, let's answer that question like this. If we call this point of rotation by the label O, we can say that the distance between O and A equals the distance between O and A prime. We can also say that the distance between O and B equals the distance between O and B prime. And we can say the measure of angle, okay, I'm going to have to use words. The measure of angle AOA prime. That's not an O, that's a 0. That's not a capital. The measure of angle AOA prime equals the measure of angle BO B prime, which equals 90 degrees. So 1-82B would be answered like this. And then you're asked to respond to the question, why does it make sense for all points P on the graph, a rotation about point O moves it to a new point P prime so that OP equals OP prime, and the measure of POP prime equals the measure of rotation. Well, we're looking at this idea that a rotation keeps the distance between all points on the tracing paper and the point of rotation constant. And in addition to that, the definition of the measure of an angle is the number of degrees of rotation of one ray to another around a common vertex. So these two ideas are related. Therefore, all the points are rotated so that the angles formed by the rays from the center of rotation to an original point and to its image must have equal measure. So that idea will continue if we were to take a different set of points, maybe at 8, 0 and 9, 2. Let's change that to 9, 2. And we were to connect those points, and we were to then rotate this segment around the origin, and let's go 90 degrees clockwise, but I would like to demonstrate something other than 90, so let's go 37 degrees clockwise, and then we want to create a segment from E through the origin and from E prime to the origin. And what's our prediction for the measure of that angle? If we've done our homework, we should get, and I'm gonna start that angle here and move around clockwise. We should get 37 degrees, right? And that label there shows us that indeed we have a 37-degree rotation. Same thing should happen with the angle created by segments from D to the origin and D prime to the origin. I'm going to change the color of the segment we just created because it's landing right on the axis. Let's make it, I don't know, how about purple? Yeah, there we go. And it goes with this guy. And let's measure that angle, and if I'm remembering correctly, I have to do this work clockwise. I want to know if I get a 37-degree angle, and there it is. There's my 37-degree angle. So this is a property that will hold, and we can take a look at our distances. They're the same length because they're copies. These are rigid transformations, so we can say that because a rotation is a rigid transformation, all figures are the same. All figures and their copies are congruent. Now I would like you to complete exercise 1-83. That's one exercise, but please prepare this for accuracy. Turn it in, have a draft ready for Monday to talk about at Math Talk, and turn it in with accuracy by Tuesday. You may prepare your copy on GeoGebra, like this one, or you may prepare your copy on paper. So I'm going to say exercise 1-83 will be assigned for performance tonight. Therefore, accuracy will be assessed. And maybe we should make that stand out a little bit. Doesn't look like I can. Why not? Properties. Let's make it bold. Let's make it bigger. And let's make it colorful. Exercise 1-83 will be assessed for performance